Hi everyone, this is Kate Trong and I'm going to be presenting a savanna biome, which is a tropical grassland. A savanna is a terrestrial biome because it is an area of land with a cohesive climate and a community of plants and animals. As for where it is located, in this map you can see that savannas are accumulated around the equator with a latitude line of 15 degrees north and 30 degrees south. It is also mainly prevalent in areas of Africa. Now I will discuss the temperature and precipitation conditions that a savanna entails, which are the climate conditions. Firstly, it is important to note that savannas have both a rainy and dry season. In the rainy season, it is typical for a savanna to receive around 30 to 40 inches of rain. As for temperature, it can get warm in the savanna with average temperatures ranging from 68 to 86 degrees Fahrenheit. It remains hot throughout the entire year in the savanna, with little to no variance in temperatures. Thus, these conditions characterize the savanna as a tropical grassland. The savanna has a lack of mountains and volcanoes, but this does not affect climate. Water plays a critical role in maintaining plant and animal life throughout the savanna because without water, no life can survive. Animals will capitalize on the wet seasons because water becomes scarce in the dry season. Because there are few trees, the air gets extremely hot. The hot air rises and influences airflow patterns, which also affects rainfall patterns. The minimal tree coverage causes temperatures to rise dramatically during the day and plummet at night. And this is the topography of a savanna. The vegetation grows near waterholes, seasonal rivers, or aquifers in the savanna because they need access to a water source. Some examples of the vegetation include scrub, grasses, and occasional trees. Plants and animals have to adapt to the long dry periods when living in the savanna. I will now expand on the important biotic factors. These types of soils commonly found in the savanna are aphisols and altisols and are prompted by how grasslands, especially savannas, have several months of dryness followed by a rainy season. These soils are very old and low in fertility, but since there is a dry season, more of the nutrients can stay in place. Alphasols are arable soils with water content adequate for at least 3 consecutive months of the growing season. Altisols are strongly leached, acidic forest soils with relatively low native fertility. They are found primarily in humid, temperate, and tropical areas of the world, typically on older, stable landscapes. The soil of the savanna is also porous, with rapid drainage of water. It has only a thin layer of humus, the organic portion of the soil created by partial decomposition of plant or animal matter, which provides vegetation with nutrients. This is an overview of what a typical food web in a savanna can look like. This is simply broken down into 3 levels of primary producers, primary consumers, and secondary consumers. However, there can be plenty of sublevels and subgroups of a food web that are not included in this diagram. Some examples of primary producers are acacia trees and stargrass. Primary consumers are termites and zebras. The top of the food web, the secondary consumers, are animals such as cheetahs and lions. These are some of the adaptations of the savanna. Migration is a process of adaptation for animals like wild beasts, elephants, and birds because they search for food and water sources elsewhere in order to survive. Hibernation is so that animals can lower their heartbeat and require less nutrients during the dry season when it is hard to receive water or food supplies. Camouflage allows for animals to blend in with their surroundings to avoid being hunted when they graze openly. And burrowing is mostly small animals hiding from their predators through digging deep into the ground. For some of the symbiotic relationships, an example of a parasitism in the African savanna is ticks on lions. The tick will drink the blood of the lion and possibly give it a disease. The tick benefits and the lion is harmed. An example of mutualism in the African savanna is with grazing animals such as gazelle. Birds perch on their backs and eat the bugs. The birds get food and the gazelle is free of bugs. Both the bird and gazelle benefit. An example of commensalism is with hyenas and lions. The lion will eat its food and the hyena will get the leftovers. The hyena benefits in this situation and the lion is unchanged. Discussing the ecosystem services, I will use the exemplar ecosystem of an African savanna. African savannas provide water, grazing and browsing, food and fuel, and medicine for tens of millions of people and have a unique biodiversity that supports wildlife tourism. Water comes from the strong wet season they have. In addition, their land transcends places for animals to graze, which also provides a food source for humans. Fuel can be extracted from savannas due to their fuelwood and charcoal prominence. Medicines, often coming from plants, can also be found through the savanna in trees such as the acacia tree. Does climate change exist in a savanna? The first issue of climate change is the carbon dioxide levels in the savannas. Recent studies show that many of the world's savannas, including the famed southern African landscapes, are experiencing significant change as rising levels of carbon dioxide in the atmosphere favor the growth of trees over grasslands. In addition, rainfall is also a problem. The frequency and intensity of rainfall influences the balance between trees and grasses in savannas and grasslands. In the driest areas, grasses appear to profit from more frequent rainfall. But when you look at wetter areas, this completely changes, with more frequent rain instead of favoring trees. These results suggest that this increase in intensity will have contrasting effects. Grass coverage will decrease in dry savannas, increasing coverage of shrubs and trees in previously open grasslands and rangelands. If trees were to win in a competition of grasslands or trees, savannas would become increasingly dense woodlands. Many African savannas are found in areas that have sufficient rainfall to support dense forests, but fire and large herbivores, such as elephants, constantly knock back trees, giving grasses space to grow and maintaining a rough equilibrium between the two sides. The increase of trees would harm this equilibrium and endanger existing ecosystems. Human disturbances. Humans have caused a lot of damage to the landscape of grasslands and animals since a long time ago. Large areas of grassland have been turned into farmlands for growing crops and rearing cattle. Sometimes fires are started by humans and they spread quickly through grasses and damage the soils. Moreover, specifically in the savanna, a large number of animals have been hunted for their valuable body parts. For example, elephants were shot for their tusks, lions were killed for their fur, and bison were hunted for their meat. Humans being in grasslands also increase the chance of fires. Human impacts are also causing widespread and accelerating degradation of savannas. The primary threats are land coverage change and transformation, landscape fragmentation that disrupts herbivore communities and fire regimes, climate change, and rising atmospheric carbon dioxide. On Earth, human activities are changing the natural greenhouse. Over the last century, the burning of fossil fuels like coal and oil has increased the concentration of atmospheric carbon dioxide. This happens because the coal or oil burning process combines carbon with oxygen in the air to make carbon dioxide. This is a savanna biome. Thank you for listening.